In this video, we are going to show how we can apply the concept of limiting reagent to questions, and from there determine the correct mole ratio, and then subsequently find the mass or volume of the products. Students, in this question here, we are given that 0.25 grams of calcium metals were reacted with 50 cm cube of 0.1 moles per dm cube of sulfuric acid. This is your concentration terms, okay? And for that matter, this sulfuric acid, that is 50 cm cube. It produces hydrogen gas on reaction and calcium sulfate. And the question goes on to tell you that calcium sulfate is an insoluble salt. Calculate the volume of hydrogen gas and the mass of calcium sulfate produced at room temperature pressure. That's the first question. And they want us to also explain why the reaction stopped. Now, first we have to write the equation. The equation is as such: calcium metal, solid state, reacting with aqueous sulfuric acid. It produces calcium sulfate because it's an insoluble salt. We leave it as solid state. Next, we have hydrogen gas. Now, in order to solve this question, we need to first determine the moles of reactants. Now, your calcium is told to you that I have 0.25 grams. And your sulfuric acid, we are looking at 50 cm cube, okay, of 0.1 moles per dm cube. Now, students, in this case, this is the first time you are encountering a question where both the quantities of your reactants are given, which means that you have to choose the correct one, okay, in order to determine what mole ratio to take with the products. In order to do that, we need to find out which one is the limiting reagent. This is how we do it. First, we determine all their respective moles. Okay, so in this case here, the moles of calcium, okay, is equals to 0.25 divided by 40, and that would be equals to 6.25 times 10 to the power of negative 3 moles. The moles of your H2SO4 is equals, because to find the moles given the concentration or volume, all we need to do is to take the concentration, okay, times the volume in dm cube. Okay, in dm cube, which means that this now becomes 50 cm cube divided by 1000 gives you 0.05, and then that will give you number 5 times 5.00 times 10 to the power of negative 3 moles. Now, you have both the quantities. Now, in order for you to determine the limiting reagent, you have to choose one, okay, of this reactant first. Now, assuming if I were to choose calcium, how would this look like? Now, when I choose calcium, what I will say over here is to completely react, okay, 6.25 times 10 to the power of negative 3 moles of calcium. Now, students, take a look with me now to this equation. If I want to completely react 6.25 times 10 to the negative 3 moles of calcium, based on this mole ratio of 1:1, I would actually need, okay, how many moles do we need? How many moles of sulfuric acid do we need? Okay, we actually would need, okay, 6.25 times 10 to the power of negative 3 moles of H2SO4. Okay. However, okay, students, in this case here, you find that, however, because H2SO4 that is given, okay, in this quantity here, there's only actually 5 times 10 to the power negative 3 moles, which means that since only, okay, 5 times 10 to the power negative 3 moles of H2SO4 is present. Okay, so since only 5 times 10 to the negative 3 moles of H2SO4 is present, you need this amount, okay? You need this. But however, only this amount is present. So which means that, in this case here, your sulfuric acid, okay, your H2SO4 is the limiting reagent. Okay, you need 6.25 times 10 to the negative 3, but you are only present with 5 times 10 to the negative 3. So which means your H2SO4 is the limiting reagent. Now, since, okay, you know this is the limiting reagent, you will use the mole ratio of your H2SO4, okay, over here, mole ratio of H2SO4 to your calcium, CaSO4, to your hydrogen, okay, in this case here, the mole ratio is 1:1:1. So which means in this case here, the moles of your CaSO4 is equals to the moles of your calcium sulfate that's produced is actually equals to 5.00 times 10 to the power negative 3 moles. And of course, that also means that because H2SO4 to H2 is 1:1, the moles of your H2 produced is also equal to 5.00 times 10 to the power of negative 3 moles. Now, from here, once you have the moles, I don't think it will be too hard for you to find the volume and the mass of the respective products. So in this case here, the mass of your CaSO4 is equal to 5.00 times 10 to the power negative 3 times the MR of CaSO4, which is actually equals to your 40 plus 32 plus 4 times 16. And once you press the calculator, you will find that this quantity over here is actually equal to 0.680 grams. And the volume, okay, of your H2 gas. Now the volume of a H2 gas, okay, because it's measured at room temperature pressure, okay, the molar volume is 24 dm cube. So what I'll have over here is actually 5.00 times 10 to the power negative 3 times 24 dm cube. And upon pressing the calculator, you should get 0.120 dm cube as the volume form. Now, the question about explain why the reaction stopped. Now, the reaction stopped simply because the limiting reagent is completely used up. To answer this question, all you need to do is to remember this, to explain in this way. The reaction stopped okay, the reaction stopped because, okay, remember how do we answer the question? We will always answer back to the question. The question asks why the reaction stopped. So you say the reaction stopped because the limiting reagent, okay, the limiting reagent, and in this case you want to name the limiting reagent, okay, H2SO4, okay, had been completely used up. Okay, so the reaction stopped because the limiting reagent H2SO4 has been completely used up. And that is your answer. And in this case here, this is the concept for your 10.3. And it has been integrated with your 10.1 and 10.2.